Long Didn't Read, the weekly podcast from the Alan Turing Institute, the UK's National Institute for Data Science and AI. Hello and welcome to Too Long Didn't Read, curated AI tidbits from this week's news. Tidbits? Tidbits. I'm going to Google it.
Please don't Google titbits.
It's interchangeable. Tidbits, it's all good. It's all gravy, baby. I'm Jonah, a content producer here at the Turing, and it's my pleasure to introduce the lady of LLMs, the Duchess of Deep Learning, the Queen of Quantum, the Countess of Counting, Smera Diva.
That was so intense, my mic fell off. That was amazing. Thank you. My name's Smera Jayadeva. I'm a research assistant in data justice and global ethical futures. Not the many glorious names that Jonah has called me, although I will take it.
Yes, you should. I was trying to get in the Viscountess of Vulnerable Groups as well.
Oh, that's the best. I think I need to be right.
Smera?
Yes?
When you look up at the stars, how do you feel?
Small, tiny, minuscule, like it doesn't matter what I'm doing anymore.
That's depressing. I was looking for something a little bit more profound and wow. Oh gosh. There are people among the human race who aren't just scared to look at the stars. They look at it with ambition and adventure in their eyes. This week, I read about how AI is helping us find untapped resources from outer space. Let's go. Outer space. Space. So the quick version here is there's a company called GenMat who combine their proprietary AI with something called hyperspectral imaging, which is basically, as far as I gather, a way of getting loads more information out of each pixel of an image from a satellite. Now, this means that they can analyse the images better and discover minerals and resources that may otherwise have remained undiscovered. How did I do, Smera?
Pretty damn good. The GenMat, I think you've covered it really, really well. But to add on to that, the GenMat model that we're speaking about right now is actually drawing on a huge amount of geological data from Comstock Mining, the parent company of GenMat itself. Quite simply, they're taking earthly geology and mining to our near solar system. We usually turn to rovers or probes to learn more about planets and understand their chemical, atomic, or mineral properties, even if it is for our mining purposes. But these mineral properties can instantly pulverize or destroy a human body. I mean, if you're on Jupiter, it's bad out there. We would not last a second. But if we use AI instead to kind of map out where these minerals might be and what we could do with it, it's a huge and interesting future for us. And with the GenMat tech, that might exactly be the future we're looking at essentially improving detecting minerals on other planets or space objects.
Okay, so we'll come back to sort of scoping out resources to pillage from outer space and the finer points of that in a bit. But first, I wanted to ask you, in a broader sense, how AI is being used in space exploration. I keep reading sort of thrilling articles about how many exoplanets and supernovas being identified by machine learning, and how AI can spot a fledgling planet forming in disks of dust surrounding young stars. It all sounds so cool. Is it cool? Tell me it's cool.
It's really cool. It's really cool. There's a bunch of like documentaries out there, and there's forms of data science that was used to train the recent James Webb telescope as well, which has given us so much insight into how the planets work. And forms of machine learning are also being used by numerous space agencies across the world, from NASA to the European Space Agency and the Indian Space Research Organization. They have used it to improve guidance systems on the rovers I'd mentioned earlier, which are these little robots that quietly traverse planets like Mars or even go across the moon. Before machine learning being used, there was a human guidance controller on the ground that moved the rover around. But now the rovers are equipped with better guidance equipment and laser navigation and the capability to make some of the decisions on where they move by themselves and send that information back. We can also take the example of the very recent Bright Transient Survey Bot, or BTS bot. It was developed by an international team of researchers led by Northwestern University, and the AI system on board was able able to not only identify a supernova, but accurately classify it. Prior to this, researchers would apparently spend 2,000 odd hours trying to identify different supernova and different explosions in the sky. But now they have more time to answer more pressing questions like, what is the status of poor Pluto? Is it a dwarf planet? Is it a planet?
It's a dog. We all know this. So yeah, there's a lot of information that's really fascinating out there. As always, we'll put links to these articles in the show notes. Coming back to the story of essentially forward planning to mine other planets, does that mean we should be worried about the Earth's current reserves of minerals and other vital commodities?
It's not looking good right now, Jonah. From natural gas to copper to lithium to cobalt, all of these minerals that are used in our everyday products, especially our tech products, there are not only shortages in these materials and minerals, be it artificially created shortages or otherwise, but the areas that are often dense with resources are frequently mired in human and ecological catastrophes. Child labor, genocide, corruption, all of these are commonplace alongside the destruction of very, very sensitive biospheres, all because we need to feed our growing desire for more objects and even better tech. So for many, mining Mars, the moon, or even Jupiter could be the answer to our material problems. And hence, for companies like this, a jumpstart on identifying the material resources on other planets could keep you in the space race, but until they actually figure out how to ensure there's frequent space travel.
Yeah, it's bonkers. I don't know if this is some sort of fever dream I had, but I feel like I remember when I was young, you could buy like a square foot of the moon. Does that ring a bell to you?
It does. I'm sure as a child I wanted to do that, but...
Yeah, like it was around the time you could buy a Baronhood or something.
Oh, that's still the case.
Quote me on this.
No, that's still the case.
Is it?
Yeah. I see a bunch of YouTube ads where they're like, oh, do you want to be a duke of this random piece of land in Scotland?
So you can be the Viscount of vulnerable groups.
Yes, I can.
So anyway, what I'm getting at is how can we, mere Earthlings, look beyond our planet and think, yeah, I think I'll have a bit of that. It's classic human, isn't it? Please tell me there's some regulations stopping big companies fly up and steal the rings of Saturn.
I mean, the rings of Saturn are gaseous, so but we do know how global markets love their natural gases. But I mean, this has been something that's been in the mind of, international communities, especially the spacefaring nations, for a long time. From the Cold War, there have been efforts through the UN to regulate space, namely through the Outer Space Treaty and the Moon Treaty. So the UN Office for...
The Moon Treaty?
The Moon Treaty, yeah.
The Moon Treaty is a thing?
The Moon Treaty is in fact a thing.
Tell me about the Moon Treaty.
But I first have to tell you the Outer Space Treaty because that came first.
Okay.
But the UN Office for Outer Space Affairs set out in the Outer Space Treaty several principles on freedom of exploration, but always in the interest of mankind. Astronauts would be regarded as envoys of mankind. And they also specify that the outer space should not be appropriated or exploited by any state. They also specifically say, do not leave nuclear arms in outer space. Like they try to cover all of these bases so that our exploration of space would always be for common good and, for the advancement of science. But they also set out principles regarding the liabilities of different corporate entities. So if, say, SpaceX went and set up shop to, mine Venus, the US would technically be held liable. And keep in mind, we're only using SpaceX as an example here because it's a very well-known and well-recognized company. It's not that there are other companies in this field that aren't of relevance to this conversation, nor that there might not be any companies in the future that might arise. The second treaty that's very important here is the Moon Treaty. So essentially, the moon should not be colonized by any country or entity or individual. But the problem with both the Outer Space Treaty and the Moon Treaty is that no major spacefaring nation has actually ratified it. So if a corporate entity like SpaceX or any other entity that might come up in the future were to actually start mining Venus or any other space object, there are no means to actually hold the company or the country in which the company is situated liable for these actions because the UN sees this as not being in the common interest of humanity. But all of these developments happened in the early days where the capabilities were only growing and the Red Scare of socialism was all the rage. knowledge. But in more recent times, NASA has shared the Artemis Accords very recently, and this is to ensure the exploration of space is transparent. Discovery on space materials should be shared. There should be interoperability, and all of this for the goodness of humanity. But again, it's the same principle-led approach to it rather than something that's contractually binding with obligations from countries and entities.
Yeah, I love how nobody has asked ET how he feels about this. So is there any hope for real regulations then? It sort of sounds like they're all saying, yeah, you can go up there, but be good. Don't do anything naughty. Is there anything more powerful in the rules than that?
Yeah, I mean, so far space exploration, because of the cost of actually getting to outer space, has largely been for scientific purposes. But now we have Amazon, Virgin Galactic, and SpaceX, looking into more potential commercial endeavors into space. But national governments, not international governments, are developing policies so they can set up a norm essentially on how these commercial entities behave in outer space. For instance, the US has the Commercial Space Launch Competitiveness Act from 2015. Through this, NASA has selected companies to collect lunar samples, but then sell it back to NASA. So essentially, you're setting up a behavior of, even though you might go out there to conduct all of these operations, that should still come back to a research organization such as NASA. But This is all to say there's a lot more work that needs to be done. And weirdly enough, even with outer space, as I say regularly, there needs to be more stakeholder engagement.
Yes.
And I don't mean bringing aliens or ET to the table, but all countries should also be at the same table deciding this, or else we're going to take our terrestrial conflicts that we're facing right now potentially to space.
Yeah. So assuming we get the regulations right and we don't go all biased and leave people out of the fruitful plundering of some unknown life form's home, this could be, for us, really good, right? Could it potentially wean us off fossil fuels and solve those kind of big problems?
So right now, as I see it, there is a focus on minerals that could give us, specifically those minerals that can give us an indication of water or even potential habitation for humanity later on. But to really show the amount of minerals that are there in outer space, with a single asteroid, minerals are so abundant that they could actually help us overcome our resource problems on Earth. Like, you could get trillions from a single asteroid in space.
Wow.
There's a lot of minerals out there. So whilst making you rich, it could also help deal with the issue that we have on conflict minerals, but it doesn't erase the problems that are there in those kind of areas. And that would still need concerted terrestrial efforts to overcome our human problems, not just get an asteroid from outer space and we'll no longer see conflict over cobalt.
That's so interesting. I love it. But we better move on. Before we do, while I was researching this segment, I was reading a really good interview with Professor Dame Jocelyn Bell Burnell, who discovered pulsars when she was actually looking for quasars, and she posed a question which I thought was really cool, and I want to pose it to you, Smera, okay? Mm-hmm. No pressure. All right. PDJBB asks, if we had access to a computer, we would never have programmed it to look for something so unexpected. How do you pick up things you don't know exist, the things you can't tell it to look for? How would you answer that question?
It's AI going to do my work for me. No, but I think that's essentially the heart of it, right? Because we're all bound by as much as I keep saying our lived experiences are important, but can also shut us out from so many of these ideas. But a computer or a machine learning algorithm might not have those kind of influences and might be able to identify that, which is why they're using it for protein discovery and drug discovery, because it can do those calculations and come up with those.
Okay, so it can find the things that you're not looking for.
But it is a very interesting question. What if it finds something, but we don't really know what it is? So it's just it's still a spot in the sky. And it just
puts it aside.
Yeah, and then we're just oh, cute, like another shiny dot in the sky. What does that mean?
Yeah. I thought I might have totally flummoxed you with that question, but you've done pretty well. Smera, I bandy around the term AI a lot, and not just when I'm talking about awesome iguanas. I've heard you and other experts mention issues with the term, and this week I was reading about new taxonomy for AGI, or Artificial General Intelligence, which to me, up to now, meant an artificial intelligence that matches or outperforms humans in a range of tasks. Is that correct? And also, in a broader way, can you tell us some of the differences between the terms we keep hearing and which ones we should pay attention to?
So your definition could be correct because there is no academic consensus or any real consensus on what AGI is in terms of an actual definition. So it's largely seen as something that has human capabilities and cognitive capabilities in particular. But AGI is not a big deal yet because we're far from achieving that.
Okay.
To put it into perspective, it's different from the narrow AI which we currently have, and that covers the range of ML models or machine learning models. And that's the first term that people should be aware of, because AI is technically machine learning and machine learning techniques such as supervised learning or reinforcement learning. So which are some of the techniques that are often used. So if you see it in a paper, it's basically the method used to train the machine learning model or the AI model. And for example, how reinforcement learning works is that if the model is given a task, if it manages to do the task, the model is rewarded and it can move to the next stage of training and so on and so forth until it manages to figure out how to, respond to different outputs that the trainer is expecting from it. Does that make sense?
Yeah, it does.
Okay.
So is AGI a big deal? I've read some articles suggesting it is the big deal and that we've achieved it. I say we. I had very little to do with
it. But AGI is not a big deal yet because we're far from actually achieving it. And AGI is presumed to be one that can do absolutely everything. So imagine an Alexa that can open your door, cook you fish pie, respond to intruders, plan your activities for the day, navigate your car, and do all of these different things without any of your input. But I'm still to find a piece of machine learning technology that can cook, let alone carry all of these different tasks under one umbrella. Okay, do it this way. Jonah, let me, to show you how the state of technology as it is, one of the biggest things of human cognition is our ability to understand logic, right? Let me give you a question. Mike's mother has 4 children.
Yep.
Amy, Jesse, and Chloe.
Yep.
What's the name of the 4th child?
Mike.
Exactly. So you got the answer, but ChatGPT was unable to answer this along with many other logical questions because it doesn't understand logic. It only understands what the next probable word should be. And I mean, that's with language. And this would be the same case everywhere else. So imagine the kind of information and cognition you need of the world in order to respond to every single thing. A single AI that can drive your car, a single AI that can, turn on the lights early in the morning. Like we're nowhere near that capability.
Okay, so we sort of understand what AGI is, or could be, or might one day be, and how that's different to narrow AI or machine learning. I want to talk a bit more about the terms themselves. In a previous episode, you mentioned you didn't like the term hallucinate, and I can see how that sort of anthropomorphizing language could be quite unhelpful when discussing something so nuanced. But I gather you don't even really like the term AI. What's wrong with that one, Smera? Why are you such a fussy pants?
I'm not a fussy pants. I've just read too much about it, and I can see why buzzwords like this can change how people respond to it. In the past, we've got instances of people interacting with a chatbot, and because it gives them a certain answer, they believe that's reason enough to imagine the chatbot to be conscious. I also use the term AI a lot until I finally got around to learning more about it. And interestingly, in my interview to actually join the Turing, one of the questions was, how would you define AI? And I'm not joking.
Oh, was it?
It was. And I'm not joking. I actually laughed and I was like, no, can I define machine learning instead? Because that's way more accurate. And I still believe that's the reason they hired me, because you're able to differentiate between using buzzwords that do not really cover the expanse of what machine learning and what data science is doing right now. And AI, quite frankly, is not artificial, nor is it intelligent. By using this term regularly, we have this assumption that AI is autonomously and very consciously delivering on the tasks that it's expected to do, but it's just not the case. I mean, I've come across when, my flatmates say our washing machine is AI, and that's just not true. It's using data science to be more efficient, but it's far from like the techniques of machine learning used in space exploration. So it's far from even machine learning itself.
But you said it's not artificial. What is it if it's not artificial?
Because
the opposite of artificial is like sentience, Smera, so it's alive. And for that matter, why is it also not intelligent? It can outwit me, for example.
No, it's not artificial in the sense that it's just an extension of our own human thoughts, processes, biases, and and all of that makes us human. So it's not artificial in that it's completely separate from the human experience, and it's completely different from the human interaction with the world, but it's literally just an extension of our own understanding of it. It has nothing unique to say about the world that we have. It cannot respond to hunger, it cannot respond to pain, it cannot respond to love. And these are all different aspects that makes us different from, a machine learning model.
Yeah.
And the reason why it's not intelligent is because our understanding of intelligence is not that simplistic. There's a really interesting way that Luis Perez Bereva explains the difference between intelligence and the automation that we see with artificial intelligence, right? He gives the example of how we have muscles and bones, but it isn't the muscles itself that make us intelligent, but it's our ability to use our muscles and use the tools like AI as well to extend our capabilities, to improve our to improve how efficient we are, and so forth. And that in itself is intelligence, but it's not merely a tool that's able to go from point A to point B or achieve certain goals that we set out to it.
So to gauge whether something is AI or not, they came up with the Turing test, right? Named after Alan Turing. Mm-hmm. Are we still using that as a test to see whether something is truly AI?
So the Turing test was far from a perfect metric when it was first devised. And again, this was at a time when any advancement in tech that used a lot of data science to give an output was just seen as absolute genius. But it wasn't a perfect metric. The Turing test basically stipulates that, and I'm really breaking this down right now, but it stipulates that for a given question, if the answer from a machine cannot be differentiated from an answer from a human by an external reviewer, then it is in fact artificial intelligence, which is very, very simplistic. And I read this really interesting article by someone who stated that, in the early days when we approached technology and, in the genius behind some of the early stages of, say, beating someone in chess, it was seen as, wow, it can beat someone in chess. That's the heights of mastery. Nothing can be more intelligent than this. But as in the years and decades that have passed, we're now at a stage where we're like, you know what? It wasn't just the mastery of like learning which pawn to move when, but being aware of that external stimulus, being aware of patterns, learning about exactly what to do when. And that's a capability that if we humans are unable to, train a model into doing, it's not going to be able to like naturally figure some of those things out. And to give a better example from that, let's go back to art for a moment. Generative AI models used in the art field only have data from the artists and their artwork, sometimes even illegally. But if we go back to some of the greatest pieces of art around the world, it was the person's life experience and general environment that made the art form and the art piece what it is itself. Take the Art Nouveau movement and Alphonse Mucha. He's my favorite Czech artist. He was influenced by the soot and the dirt and the grime around the Industrial Revolution that came from the factories in Czechia where he grew up. And he painted in very flowing, colorful, and emotive ways in a way to really mask all of that dirt. But if an AI was there right now, would it be able to make those connections? Would it see the dirt how we would maybe see dirt, and would it see a beautiful lady for how we would see a beautiful lady, and a peacock and roses and things like that? It's not going to respond to those ideas unless we tell it, oh, this is good, this is bad. But again, it's not doing naturally, inherently.
Yeah, and I suppose AI won't be able to create true art until it becomes AEI, artificial emotional intelligence.
Yeah, and that's why it's important to see AI as a tool, not a creature, not a sentient being.
But I suppose it can scrape the academic explanations artists or critics have given that do exist online. So the only way to protect your art is to never explain or contextualize it, which is the artist's prerogative. I wonder what the next art movement will be. It'll surely be like a backlash to AI.
Yes.
It's going to just become really abstract or really organic or hyper something or other. Interesting. Watch this space. This week, I was interested to learn about a farm that used AI to make it more efficient. Now, the article I read was about a farm using AI to control the environment inside a greenhouse to grow the perfect strawberries and robots to harvest them. There's obviously lots of larger issues with this example, such as the limited biodiversity of a greenhouse, the missed opportunities for pollinators, as well as the ethical considerations of monopolising the growth of a seasonal fruit that some people might rely on. But first, Smera, can you tell me about the wider range of AI use in agriculture?
So as with many uses of AI, or as I've said before, machine learning in agriculture, it always comes down to leveraging data science. And you use that to identify issues, provide solutions, and chart future pathways on where a crop can go or what the soil is going to look like in the future. And with increasing global warming and absolutely unprecedented weather anomalies, which can destroy crops and lead to soil issues, there's an increasing need for having better access to data that can inform our decisions as we move forward. And if we are able to use the data from the Met Office, and trust me, there's a lot out there, and data from global crop harvests and different methods of fertilization, we can probably plan better how to sow, when to sow, and what to expect in the future.
Yeah, okay. So there's so many interesting and hugely complex problems that agriculture poses. I assume there are real opportunities to solve some of them with machine learning or AI tools. I can picture like animal welfare being monitored better, flood risk due to topsoil inadequacies being spotted sooner, increased biodiversity on both arable and pastoral farms, and maybe even being able to decrease the amount of land and monoculture thanks to bigger and better data sets and AI implementation. Is there a hope, Smera?
Yes, there could be. That
didn't sound very convincing.
Because it's important to have meaningful partnership with farmers.
Yeah.
I mean, I know I keep saying stakeholder engagement, but I cannot emphasize it, especially in this sector. If we do the tech will save us route, we risk this problem of having people who are great at math and tech deploying a tool on a farm without any knowledge of agriculture whatsoever. I mean, so this all really resonates with me, and it might sound like I'm on a monologue right now, but agriculture and farming is not just any other industry. It's the backbone of many communities and many countries around the world where a large part of their population is engaged in it. And if you see the scale of devastation and destruction that happens, and how the farmers are treated at the end of it, that they're not included in some of these decisions, and how a lot of the cropping methods are done in a way that responds to global markets and global demand rates for a specific type of vegetable that cannot be grown year round, and the scale of like vegetables that need to be produced to feed that global market rather than the vegetables that they need to ensure that soil fertility and ensure that they keep reaping those rewards. It almost feels like it's a repeat of what happened, under the British Raj, where farmers were often expected to grow cash crops like indigo to feed into textile manufacturing in Manchester, but not grow the vegetables that they needed for their own sustenance. And this is why this is all to say that it makes me really passionate about this, because this is a huge element of the country that I grew up in.
Yeah. I don't think you need to apologise for having a monologue there. I think you're very entitled to one. And I think that a lot of our listeners might be similar to me and maybe thinking of sort of Western farming when we talk about agriculture. So I think it's really important to bring in different perspectives into the conversation. And I imagine that we also need to be careful about the huge amounts of data agriculture might be offering being used in questionable ways, right?
So as with any other domain or sector, there are the regular data worries like data breaches and thefts, which, often tend to take place. But in specific for farming, we need to think about the infrastructure itself, be it digital or internet infrastructure, and whether that's reaching all of the rural areas where farming is there, and to ensure that they have a regular connection to the internet. And with farmers, especially in areas where the farmers often have to give up their education to continue tending to those lands, are they still equipped with the digital literacy to respond to different anomalies and tweak the systems as and when there might be faulty data or faulty outputs? And finally, to bring it back to the data point as well, big companies can monetize the data without those profits actually trickling down to the owners of the data itself, the farmers itself that are interacting with these systems. So those safeguards have to be put into place before these systems can be deployed in a meaningful way.
Yeah. Better strawberries don't seem like quite as big a win now. I remember, on a positive note, we did some interesting work at the Turing about a digital twin of an underground farm, right?
Yes, this is a really exciting project. And Growing Underground was a company that had a focus on zero carbon food, and they built these underground farms in disused World War II air raid shelters in South London, very close to Clapham North.
Cool.
And the Turing has come in with this program to optimize crop performance and reduce energy use. And they're led by Ruchi Chowdhury in the Turing's data-centric engineering program. And you can learn more in the sources that we add. But essentially, the crops are grown using less space and water than conventional greenhouse growing, no pesticides, and 100% renewable energy system. I think it's really interesting. And apparently, you can get these in the new Covent Garden Market.
Oh, wow.
The produce.
Yeah, that's pretty cool. Good work, us. By us, I mean them. That's about it for this week's Smera. But first, what do you have to feel positive about in the AI world?
So it's kind of an extension of our previous story on agriculture. I did mention the use of data from the Met Office and other meteorological data that can help predict the weather a lot better. And it seems that there are many, many companies that are now improving their models, and they're developing neural network-based models for such as GraphCast by Google's DeepMind, which can more accurately predict weather conditions, including anomalies, especially at a faster rate. So previously, the Met Office would take a long time to compute some of this data, and not only was it time consuming, but it was also energy intensive. But with these new neural networks, it can all be done a lot quicker and with much faster computing. And to give another shout out to a lot of the work that the Turing is doing.
Woo, Turing!
The Alan Turing Institute is now partnering with the Met Office on a new collaboration to use machine learning and advanced technology to help predict the weather. They will be using information from satellites and observational data, as well as running simulations on a supercomputer to run forecasts that will help millions of people, especially in the UK. And this will not only help predict with more accuracy anomalies in weather and unprecedented weather conditions, but this information can help communities increase their resilience.
Well, that is good news. Thanks, Smera. As a Brit, talking about the weather is very comfortable territory for me. I could go on, but I sense a musical interlude coming. That's been Too Long Didn't Read. We read so you didn't have to. We learned that us ever-pioneering humans will soon be exploring Uranus for vital minerals. We learned that it's fun and possibly important to be pedantic about the terms we use for these tools. And we learned that although in its infancy, the use of AI in farming could help bring about significant changes, as long as we temper those changes with balance.
Oh, can I do the thanks to our team, the whole team?
Oh, yeah, you can do that.
Big thank you to you, Jonah. What was your name? Did we give you a name?
Jonah, my name's Jonah.
No, I mean, did we give you a name? Did you, the creative dictator of creative something? The count of content.
Yeah. Oh, yeah, I'll take
but
that.
Also, very importantly, a big shout out to Jesse, our jester of justice, who sits behind the scenes and makes sure we continue to stay on track and address the big issues at hand. We would be nothing without her.
Also, thank you for listening. Find us on Instagram at the Turing Inst. Email us at podcast@turing.ac.uk. Click the linky followy like buttons, and then thank you, Smera.
Oh, thanks. You're welcome. Anytime.
Bye.
Bye-bye.